1, 2, yep. Okay, we're into the last two sessions now. A change of who I was running it. I'm Ken Eaton, GW1FKY, so I'm doing it on behalf of AMSAT for this afternoon. Just before I do that, Jim has asked me to make two announcements regarding the raffle and the auction last night, and also the money involved in the silent key. In both cases, it was £900 in that region of, so nearly £1,800 as far as we know at the moment. So thank you very much indeed. You've done a grand job indeed in supporting AMSAT. Thank you. Okay, now to start the sessions. I don't think I need to introduce our first speaker this afternoon. There was a lot of fluff about in the beginning. Everyone was showing great interest in the phone sats, and with STRaND-1 everyone was ready for it. And what it was a success. I'll leave Chris now to give you an update on the background to STRaND-1, and I'm sure you'll enjoy that. Thank you.
Well, thank you very much for the introduction. Yeah, I guess the first thing to say is just to follow on from what Dave said, and it actually has been a great help. There's many people that I've met actually at this colloquium that either I've met before or I've only met on the sort of bench line of me doing pieces with AMSAT. That have actually received a signal, and it's actually wonderful to meet various people that have sent in packets, even if it's 10 or even if it's thousands, like certainly Mike has helped with. So big thanks to Mike to helping us in STRaND. And so this is the STRaND signal, as you would see it. This is taken with a FunCube dongle with our DC spike there, but you can see there the sort of rough shape of the signal there. And so for those of you that don't know what STRaND was, STRaND was a, well, the acronym is Surrey Training Nanosatellite Demonstrator. Okay? And the real point of that was to try and figure out how we could work with the very latest COTS technologies, okay? And see if we could understand them, their capabilities, and their risks. So in our case, we chose smartphones, okay? And we chose them for a few reasons. One, apart from solar panels, it is pretty much a satellite in your pocket, okay? It has a computer, a camera, memory, a battery. It has all the regular things. You don't want Bluetooth. That's never going to work to ground. But it actually has all of those parts that you need, which is essentially almost a satellite. And it's whether or not we can take advantage of those particular technologies. The other part to that, really, is that the technologies that we typically use commercially to launch things into space are made on older technologies, okay, sort of above 90 nanometer technologies, because they're reliable in space. They don't suffer greatly from single event effects, and they can take a lot more energy in the silicon before they become problematic, and they cause errors on our spacecraft. The problem is with that is that those foundries are actually being reduced. I think there's only 2 left in the EU, I think 4 or 5 left in the world that are doing above 100 nanometer technologies. And nowadays, all the stuff you've got in your pocket, or sitting in your lap if you've got a laptop, is now moving to 13 nanometer sort of technologies. Okay? So particles that we have that come certainly around our solar system is, let's take for instance an iron atom, one of the largest things that comes out of our sun. The impact area of that can be up to 90 nanometers. Okay? So if you have actually parts on your satellite, okay, that are now much, much smaller than that, it's not just going to affect one area, it's going to affect multiple areas. And we have something called multiple bit events, not just single bit events, which can cause burn-ups and latch-ups and other effects in space. It's actually going to take out large areas. And because of the way it's mapped on a device, it isn't just they're all in one nice, neat little block that you can just then avoid. They're mapped here, they're mapped there, there. So when you take out a small block here, you actually take out multiple blocks all over the places, just because of the actual architectures of memory for efficiency themselves. So this was really one of the reasons why we looked at mobile phones. The other challenges that we had were to challenge internal processes. Internal processes, whether it's with documentation, restrictions on purchasing, things like this. And we wanted to explore them together with SSTL, see if we can make that chain somewhat leaner. The other part really was to provide rapid exposure to our new staff, our new students, and to new graduates at SSTL. And Mamuth here, in fact, is a great example of that, who's recently joined the Space Centre after doing an MSc and got chucked in at the deep end as a baptism of fire to work on STRaND. Okay? And as such, that she can come out with that experience, as well as some of the other undergraduates. So we actually had 3 or 4 undergraduates that worked on STRaND as well, and I think 2 of them have been employed by SSTL. That's one of the great things that they can do. They've already had that exposure to that sort of hardware. So this is one of the, again, geek porn shots, as Wouter and Graham would lovely put it. And you can see here, STRAND-1, again, it's a 3U CubeSat. The real differences that we have here is we have our PC 104 standards, excuse me, and then we actually have our payload bay. And the payload bay itself here is where we actually put all the non-conforming items. Not everything we do is PC 104. It's actually quite a big interface. It takes up a lot of room. And we have other components that we wanted to put on there. So the mobile phone, our reaction wheels, the magnetorquer rods, the GPS receiver, all of those things were mounted in this particular bay here. And what we actually have here is we have Dr. Pete Shaw here. He's a researcher at the university, as well with 2 SSTL employees, Nimal and Susan here. And they're people that just wanted to get involved and they were enthused by the spacecraft. So what did we learn from this? Okay, we wanted to assess those things like what I was saying. Okay, we wanted to assess the cutting edge technology, whether or not it can be used. Well, we looked at that, looking at smartphones and the existing CubeSat hardware and software. Is there anything we can learn from that? Okay, and as such, we learned a lot just as a university, and as well as SSTL did as well, to try and figure out what they could do and whether or not there's anything they can improve. Now, having a CubeSat comes with its own set of problems. Unlike typical missions that we would have at SSTL that would have redundancy and they would have a lot of fault tolerance on those, CubeSats don't have the luxury of either the mass or the power budget to be able to do those things. So what can we do in that place? Okay? And that's brought around some new ideas and some new thoughts that we want to be able to spin into the other parts of the missions. Reviews, these are absolutely necessary. They help you to reduce your risk. Looking at the processes that we have, they were already good enough. Okay? You do need your PDRs, you do need your CDRs, you do, unfortunately, need your documentation. Okay? It's a shame to say it. Okay? Don't shoot the messenger. That's just the way it is. These particular reviews here are really necessary because it helps you to reduce your risk. You need to be able to manage that risk and know where you're going to put resources and people and time to work, actually, as Wouter put it quite so eloquently, on some of these very, very short timescales. And in particular for strands, is that we had around just over 3 months to go through our AIT phase, okay, which is taking all the parts that you've seen perhaps on the BBC and on the news, and actually finally put it all together and actually make a functional satellite. And 3 months, I can tell you, is a very, very short piece of time. So for those of you that saw my talk last year, is we had a lot of the pieces and the components, and we were all looking like rather fresh-faced. Obviously, I don't look that way now. Obviously, I've gone through my own baptism of fire in that way to be able to get this thing done. But we successfully did that, and we launched on the PSLV in February. The full paper, which actually goes into a lot of the nuances with either the CubeSat hardware, the I2C bus, the architectures, what we'd actually learned is in a paper at SmallSat in Utah, and they get you to sign this wonderful disclosure form saying you're not going to tell anyone else about it first, so that they can release it first. But that paper will be publicly acknowledged, and you'll be able to pick that up on the SORI website called ePubs, which has nothing to do with pubs or an electronic form of pubs. It's publications, not public houses, which you'll be able to find. Yeah, I know. What can you do? Which you'll be able to find there online. But it was fantastic, and we had a really good time to be able to figure out how we would then go away and build all these parts. So the first thing that we did, after we all partially collapsed from building it, from some very, very long nights and weekends, often with not a lot of sleep, is we put together an EM, okay? We did that actually after we put together the FM, okay? So with any spare parts that we had, we could put together our engineering model, and it includes things like the computer, a power system. These H component boards here, they were actually, we really did pack everything into Strand, and the H design for those particular PCBs is because we actually had cameras that would fit in the bus, and they were mounted like this, so the cameras were mounted like that, and we had to put our switchboards on there. And any other pieces that we could find. So in our case, the phone, we had a webcam which looked at the screen as well. We have a wheel, we have a rod. So we had a couple of spare bits and pieces. We put that together to really try and test and push forward our ground station. Now, the ground station was also not very much, wasn't very tested as lot as we would like to have done. It was never really used for transmit. It was used as part of the Genso collaborations, and I've always only ever used it for receive-based functions. So getting it ready for transmit after we'd have everything ready and during our AIT just meant that we didn't put enough time and effort into the ground station, and it wasn't ready on time. Key things that we found were problems. We actually were using just old computers. old computers really lagged when you were trying to run ham radio Dulux or Orbitron. We had to get rid of them and replace them very, very quickly during the first sort of week to make sure that we can control our software really to do the correct Doppler as well as controlling the rotators effectively. Ham radio Dulux, in fact, we're not going to use again. So we're currently using Nova and we're using Orbitron to do our mission. We tested transmissions as well farther away, even at lower powers, just to try and see what we could do. Now, the real problem that we had was with our uplink. And once we sort of finished and found those pieces, as well as an improvement in the TLEs, what we'd actually found was that actually we were transmitting all the way across to Farnborough. In fact, there's actually, this is me. We had our own TNC. This is a guy called Bob. He's another amateur radio enthusiast. And we were actually getting perfect data back, 10 miles away, simulating the actual link budget that we would have gotten. And in fact, we even chopped it down even less. So Mamartha would have been more operating in the ground station. We'd be receiving the other end, just to make sure that our uplink was working. And it turns out that it was fine. We were picking up every byte, every packet. Okay? And what we actually could simulate, and after all of the hard sort of time of trying to figure out what was happening with our uplink, was that actually we think part of the VHF antenna was perhaps still stuck in, and it was sort of a loop, and we were weren't getting as good connection with our uplink. But still, on good occasions, when it was good, it was really, really good. But when it was bad, it was bad. But as such, this is really what it looks like. Hopefully, that should just start there. And so you can see the signal there. And actually, it was a very, very good signal with about over 1.3 watts of power into this particular signal. And it was fantastic getting that back down from Earth. It was a real buzz for the students and for the staff that had worked on it. So we were a very sort of young team, sort of 10, 15 people, building up our capability at the Space Centre. The things that have come out from that now is we've actually got our own clean room. Okay? We've got our own clean room, which we can, hopefully some of you that have been around the Space Centre have seen from Friday's Bring Your Own Boards Day. And also now a much more functional ground station that we can then use and expand upon with the students on campus. Now, STRAND-1 currently isn't transmitting at the moment. There was a geomagnetic storm, and it took us out briefly. We recovered. It went into emergency mode, and we brought it back, and then almost a day later, it stopped transmitting. It also took out a Canadian spacecraft as well, an actual quite large Earth observation satellite called RadarSat. And unfortunately, neither of those two craft have been able to be recovered yet. We are hopeful for November. November is actually when we have our eclipse period. We just need the whole bus to reset and come back on. And that's really what we're looking for. But in the meantime, I don't give myself any breaks, is actually we're working on other missions. We're working on CubeSail, which is hopefully going to be the first UK solar sail and deorbiting mission. For those of you that went to the Bring Your Own Boards Day, you'd have seen the 5x5 metre solar sail that we have in the lab. And it's absolutely huge. You can see it there, the flight model that we're working on, and you can see how we wrap it up. We take this 5x5, which is almost the size of this room, almost. We wrap it up into 2 U's, okay, and it's really just specialist origami and mechanical fittings that go on that. They use carbon fibre booms that then wrap it all around. The next mission is REST. REST is a reconfigurable telescope with Caltech out in the States. I'll show you some pictures of those things. And then STRAND-2 and QB50 further on from that after we've gone through all of our processes we need to do here. So sort of moving on to CubeSail. One of the things that I wanted to show you, just to give you a bit more of an idea how much stuff is up there. You've seen some things, okay? These are just active satellites that you can see. And what I do is I actually then start to check boxes. This is my own Google Earth plugin. I mess around with software, for those of you that haven't met me yet. We have rocket bodies, bits of rocket bodies, and then when you see all the dots come on, these are all the dead pieces. Okay, so 32,000 of those, 18,000-ish that are actually active. There's a lot of stuff up there that is dead. Okay, and if you want to see the plugin working afterwards, I can show you it all, and it's actually moderately horrific. So CubeSail is actually going to be demonstrating how they can deorbit actually all of that material. Okay, all of that material is there's a lot of it, and has been said in previous presentations, we need to find a way of bringing down those spacecraft and bringing them down end of life. Okay, and that has to be an autonomous operation. Okay, whether or not these things go on an actual mission, or whether or not they actually go on as part of other missions. But maybe we want to think about actually having something that's attached to a spacecraft or a LEO spacecraft or any even rocket body parts where it actually deploys automatically. Not on a command, it has to be happened automatically. So for instance, if it's not had an uplink for 2 weeks, just deorbit, open the sail, bring it down. Something as simple as this. It's got to be one of those things that we can try and do what we can to do to bring it back down. And so this here is a simulation of the CubeSail attitude. Now, CubeSail isn't just looking at deorbiting. Like I said, it's looking at solar sailing as well. And in this case, one of the things that we're looking to do is change of attitude with the sail, but also change of inclination, changing the actual orbit of the satellite as well, by orienting the solar sail spacecraft in certain directions. So this is the sort of animations, excuse me, animations that we produce over in the Space Center from Professor Lapis's group. He's kindly let me look at these videos, and as well as his researchers, Laurence Visage, in fact, who's really, really good at creating these sort of animations and bringing to life all the little pieces and all the calculations that we do. Now, ARREST is the reconfigurable satellite system that I was talking to you about with Caltech, and it essentially is contained within six CubeSat, 6 3U satellites. Okay, and in these 6 3U satellites, you have 2 sets of mirrorcraft, which would sit on top of these plates here, and then you'd have one optical part at the top. Okay, and what we would actually do is these parts here would come off, separate some of the mirrors. We would then rotate the central body, and then we'd bring them back in. Okay, and what if you went over to the Space Center on Friday, you'd have seen actually the beginnings of all of the technology that we're developing to try and make this into reality. And that includes our granite table, which is a very, very large, essentially block of granite, which is very, very flat. It's 1 micron, in fact, flat. And the pucks that we've built and the robots that we're going to be bringing together to be able to do the rendezvous, the docking, as well as the communication between the satellites. But what's great about these sort of technologies, and this is a picture that I took up in Glasgow of Andy Green and David Willits when they were talking about UK space and what we need to do for upstream and downstream. Okay, that's some of the pieces that perhaps us scientists aren't necessarily too worried about. Is that he was saying that we need to be spending that money that we do have on really disruptive technologies. We've heard people talk about disruptive technologies from ISIS, and as well, SCube are doing a really great job at seeing what they can do with their CubeSats as well. But you can see here that they've actually got a picture of STRaND right slap bang in the middle of one of their UKSA slides about these disruptive technologies that we need to keep funding, because it's those sort of risks and things that are going to eventually push us through into the sort of next state to make sure that we have their end goal, which is that sort of 10% of the global market within UK space. So, what have we been doing recently? Well, this is more in preparation for CubeSail. One of the things that I've been working on and towards is the computing part, as well as the communications with CubeSail. And what I've got here is a demonstration of GNU Radio. If you haven't seen it, it's an online tool which allows you to put together DSP blocks, which essentially will allow you to do the filtering, the demodulation, capturing the audio. And what I have here is I'm decoding here PhoneSat. You can see here, this is the spectrum. You can see PhoneSat signal coming in here. So it gives you an idea. But what you can actually see in this top screen here, this is the audio. So when you see an actual signal come in there, you should see the audio come in, hopefully he says, like that. And then you get your message come out down here. Okay. This is essentially your software terminal node controller. This is your TNC that you want to be looking at using. And these are tools now that are starting to become available quite readily, and they actually work very well with all the new dongle technologies, the FunCube dongles, the Pro Pluses, all of these different tools out there. And it makes it very, very accessible, and you don't pay for it, which is the important part. Now, why is this particularly important? Now, we've been looking at software TNCs and actually looking at them and comparing them against our hardware ones. Now, we have 3 TNCs at the Space Center, hardware ones, and comparing them actually with the software ones, we found that we actually lose packets using our regular TNCs, and we actually lose packets when we just use some software decoders. So what we've done is we've been comparing the MIX-W is the Ukrainian one that's very, very good for decoding. But then we've been looking at other packet engines and seeing where we can actually make our own amendments to these open source tools to actually pick up every packet. And so what we typically do is we use our SDR front end, okay, whether that's a FunCube dongle, a DVB, dongle USB radio. And what we do is we record it typically in SDR#, the INQ file, and then we then play it back in GNU radio, or you can do it live if you so wish. But we record it so that we can check on, play with our filters. And SDR#, for some reason, we found actually works very, very well. It's a fantastic tool, but we weren't sure why. Why was it giving us 10% more packets? And the real reason that we think is just the way that the decoders are written, the way that they've handled modulation and handled demodulation. They have certain nuances, okay, whether it be with packet length, whether it be in the fact that they do or do not start things in their own version of the AX25 standards, particularly in the HDLC, very, very first layer of this digital sequence. And sometimes they'll just drop packets, which is awful. If you need these packets down and you're trying to get down telemetry, you need to have everything. If it's a compressed image that you're looking to get down, then if you lose any parts of that packet, you've lost your whole image, certainly if it's JPEG. And so what have we been working on? What we've been working on is we've been trying to extend Alex's essentially GUI decoder, okay, which is called QTMM, QT Multimon, excuse me, so that you can actually then take either a raw output or whether or not you want an ASCII output, and then actually have just a Dropbox for your modulation and data needs, okay? And this can be AFSK, BPSK, 1200, all the way up to how quick your processors can actually go, okay? And so that's the sort of tool that we really want to have releasing and getting ready sort of for UCube and for other missions, certainly for QB50. We want to be able to put this up on the Surrey website and say, this is yours, just use it. We'll compile it for Mac, Linux, and Windows. Bob's your uncle. That should just be it. And what's really good is we could verify this with the STRAND signal, ones where we know that we've dropped packets in other forms, and then actually pick them, every single packet up in the STRAND-1. So we've actually had 100% back on some cases. And just to really put it into context, this is really what you can do with these sort of tools. You can have your laptop, which has a FunCube dongle, okay, and we can actually then decode NOAA's imagery as well. And so you can do all of that without the need for anything, okay? And we wanted to be able to have that nice, neat package that is just easy to use. So, where's next? So one of the things that I've been working towards, and working actually with the CubeSat community, certainly in the UK, is sort of moving on from meetings that we've been actually having for the last few years, whether it be in the UK or whether it's been at ESTEC with ESA, that actually there's a focus that's needed in the UK with our nanosatellite community. And what's really great about this is that having such a diverse sort of set of people means that you've just got so many different requirements that some of them conflict and some of them don't. But we need to have a sort of clean interface with certainly the UKSA that allows us to be able to facilitate and strengthen what we already do. Okay, we want to get our kit into space, whether it be for money, for kudos, or because just it's totally cool. But one of the things that we need to be able to do is try and do that and do it ourselves. So one of the things that I'm working on is with myself and with the University of Cranfield is that we're going to be heading up this new forum, which will include industry, academia, entrepreneurs, amateurs like yourself. And so any thoughts on that sort of on the CubeSat community, we want to pull together those so we can help give a clear direction, okay, and help have a sort of unified sort of response to whatever is happening within the community. And these can be all sorts of things, whether it be things that need to be happening now, sort of fixing the Outer Space Act, I'm sure we've heard about that, but also things like, I didn't know that Cranfield was working on this, or I didn't know that Surrey was working on this. And so one of the things we want to set up is a brokering website where actually people can put on their information, and then it's an actual contact sort of area, so that if you wanted to look for someone that works in astrodynamics, solar sails, control moment gyros, all these different things, and there's actually a UK contact. And then you can start matching people up. Because you actually have a lot of different separate types of people. You have people that do space engineering, like myself, where we build buses, comms, OBCs. And then you have people that build payloads. They build magnetometers, and they build all sorts of other things. And they don't care about the bus at all. They just either want to buy one, or they want to find people that can help them figure it out. Okay? And so that's really the point of the new broken website. And so far, we've got a sort of small set of people to help sort of bring it up. But do watch this space. We'll be bringing out a paper which tells you about the remit and what we sort of expect this sort of forum to do and how it can help us all in the future. And so that really ends the sort of update that I wanted to talk about with STRAND. And I wanted to leave you with one of the things that we've been doing recently, which is moon bounce. Now, my mother is one of the senior members in our EAR Society. This is the Electronics and Radio Amateur Society at the University of Surrey, and she's been helping them put together and manage doing the moon bounce. She's right there. Do talk to her. Sorry, my mother. But they've been working on this, and they've worked really, really hard to get a moon bounce. And we did get a bounce back from someone who was transmitting from Andover, and then we can see the CW signal come back. And that concludes my presentation. Thank you very much.
Any questions, please, in-house before we look on the internet? No?
I've covered everything,
no?
Clearly.
Nothing? Graham, one moment, yeah.
I can repeat it if necessary.
Sort of semi-techie question, Hummingbird.
Yes.
Did I hear you mention Hummingbird?
No, so we used Hummingbird for our engineering model, and it was a question that I need to actually ask the SCube guys actually after. So Hummingbird, as they've discussed, is a mission control client. It's a big piece of software, which is actually quite complicated to be able to put together all of your dashboard like you have with FunCube. Okay, and one of the things that we built at Surrey was the HDLC layer decoder. Okay, so we built that decoder, and that should I hope, it's open source, and you can go ahead and download that and then start using that tool if you wanted to. Now, what SCube done is they then brought in other parts and other pieces, and I don't know whether or not that is open source. So those pieces, I don't know if they've been brought out. I don't think they currently are available. But all the pieces that I've done are out there. All of the code for the phones, for the phone sat stuff, we've decoded their packets. All of the pieces like that, I've all put up on SAndroid. So that's Space Android, and you can get everything and all the code there that we've ever done. Okay, it's all open source.
Okay. Yes, thank you. Because I've heard about heard of Hummingbird quite a lot in the last few months, and I'm not sure just whether we, as AMSATs around the world, should try and pick that up as a standard for ground station mission control things, or whether it is too complicated or requires too much individualization for each project. Blah blah blah.
So I'm hoping not. Yeah, let me give you a bit more background about Hummingbird. Hummingbird comes out of the enterprise software industry, and that is essentially a huge batch of software that they use to do telecommunications and to do networking around the world. It's based on Apache and Camel, and they're two very distinct computer science software tools that are very different to what we want to do here. Now, amateurs, and myself included, we want to get bit-level stuff. We want to connect ports up to bits of software. We're not worried about abstract, high-level, different ways of doing things. That's not really potentially what we're interested in. Hummingbird doesn't do that for you yet. Okay.
Thank you.
At some point in the future, hopefully it will be. There is this base part that if you wanted to download and get it and play with it yourself, it was okay for me, but I do mess around with software a lot myself. I'm sure you guys, you can absolutely do it too, certainly if I can.
Anybody else? No. Well, before I say on a major scale, thank you to Chris, I'd just like to say, Chris, I'm from South Wales, and we do lots of major events in South Wales, which involve schools, education, and amateur radio. And during the opportunity of STRAND, we had VIPs as well. And during that presentations and school visits, I used to talk about phones. And you won't believe it, but even VIPs and teachers didn't know that they had a transmitter and receiver in their hand. But what it was, it became a major talking point for me to move forward and talk about our own CubeSats and the FunCube dongle as well. And that was also a pointer for them to wake up and say, yes, there's some education that we can learn here. We can look about careers and go to university, and also maybe have engineers and also enjoy amateur radio. But thank you to Chris and his team. It's been very useful, and we look forward to giving you assistance in the future. Thank you.